ఎక్కడి నుంచి ఉరికే? Good evening all. Today we start push down automata, and thank you. I am feeling good, Mr. Abhijit Verma. So PDA I'll take almost 3 days. Okay, I'll complete. So in this PDA, first we see the design structure, and then how to write the moves. Then how a PDA can accept the strings, okay, and then what is DPDA, what is NPDA, then how to design a PDA. After that we will do some designs. After that I'll tell you how to check a given given language is deterministic context free or context free. Then we'll go for properties of CFLs. These are the, so we'll see the structure, then design part, then how to decide a language CFL or not, then properties. Okay, chalo, you start. Suppose I take one language. Tell me guys, is this regular or not? Are you following? Is this regular or not? It is not tough topic, it is easy, Ritu. It is easy, I'll make you simple. Okay, but initially you please concentrate. So you people don't use your phone, don't see WhatsApp, nothing. Please concentrate here. Whatever I deliver, even though you are not getting, don't worry, at the end you will get everything. Okay na? Whatever I am delivering here, if you receive only 50% or only 30% or let it be 10% you are receiving, no problem. So at the end you will get everything. Okay na? Just believe me, and switch off your phones. Okay, just this is very important topic. Yeah, now so guys, this is regular or not regular? No, it is not regular. Why? Because we cannot construct a finite automata. Okay na? This is not regular because to accept this language we cannot construct a finite automata. Okay, then why we cannot construct a finite automata? Because in this language whatever the string we take, the number of A's followed by number of B's, and A's and B's must be equal. So if I give a string A power 10, B power 10, you must accept. At the same time, if I give A power 10, B power 11, you should not accept. So that you have to consider the finite automata. Therefore here there is a comparison between A and B. You have to read the A's, you have to read the B's, and you have to compare whether A's and B's are equal or not, which is not possible by finite automata because we need a memory. Finite automata has the memory, but that is finite memory. Here how many strings will be there? A power 100, B power 100, yes. A power 1000, B power 1000, yes. A power 1 lakh, B power 1 lakh, yes. A power 1 crore, B power 1 crore, yes. Then see, if this is A power n, B power n less than or equal to 100 or less than or equal to 1000, we can construct because they are finite. But when greater than 0, how many strings will be there? Infinite. So you have to store A's, you have to store B's, and you have to compare. For that a memory is required, but a finite automata does not have the memory. Therefore we cannot construct the finite automata. We cannot construct the finite automata to accept this language. Hence this language is not regular. Okay, then what kind of finite automata accepts this language? What kind of finite automata we can construct to accept this language? That is PDA, push down automata. We can construct a PDA to accept this language. So push down automata. Okay, you construct PDA or any DA, any automata, you have to count the A's and B's. You have to compare the A's and B's. For that, we must require a memory. Yes, PDA has the memory. That memory is nothing but stack. So using the stack, we can construct, using the stack, we can accept these kind of languages. So stack, or we can call it as a push down store, PDS. We can call it as a push down store, PDS, stack or PDS. So a stack will be there. A stack is a data structure. Stack is a data structure which is used to push or pop the symbols. It is a data structure. We can push any number of symbols and we can pop any number of symbols from the stack. So PDA, okay, is used a memory which is nothing but stack, that is push down store. Using this stack, we can accept these kind of languages. Okay, mainly the PDA is used to accept context free languages. The PDA mainly used for accepting context free languages. Okay na? Now, okay guys, now just take the notes. Take in PDA, no, take PDA, then no, just only take PDA. PDA is used to accept, PDA is used to accept context free languages, like this. PDA is used to accept context free languages. Okay na? Next. Now, in PDA, a stack or push down store. In PDA, a stack or push down store within brackets PDS will be used as a memory, which can be used to push, or pop the symbols of the grammar. Okay. Okay, next. So this language is not regular. This is not regular because there is a relation between A and B. Comparison between A and B. Comparison is infinite, so not possible. So to construct a finite automata, therefore not regular. These kind of language will be accepted by other automata, that is PDA. So in PDA there will be a stack, okay, or PDS, you can call it as a push down store. So simply we call it as a stack. So there will be a stack which is used to which can be used as a memory and which is used to push or pop the symbols of the grammar. Okay na? And mainly the purpose of PDA is to accept context free languages, Okay, now we see the structure of the PDA. It is a 7-tuple It is a 7 tuple. 7 tuple. Generally we represent M stands for machine. It is a 7 tuple. Q, sigma, tau, delta, Q naught, Z naught, F. Q, sigma, tau, delta, Q naught, Z naught, F. It is a 7 tuple. Okay, what is Q stands for? As usual, Q is finite, non-empty set of states. Finite non-empty set of states. Q is finite non-empty set of states, and sigma finite set of inputs. Finite set of inputs. Okay, and this is, so I told you there is a stack, and in the stack whatever symbols we push and whatever the symbols we pop, they comes under stack symbols. Okay, so this finite non-empty, this is finite non-empty set of stack symbols, or we can call it as a push down symbols. Finite non-empty set of stack symbols or push down symbols. Okay na? And this is transition function. This is transition function which describes the transaction, Okay, so just look at this one. What is trans function? We will see later. Okay, so just copy. I'll explain this clearly, but as of now, you just copy this one. So it is Q cross sigma union epsilon. Q cross sigma union epsilon cross tau into Q cross tau star. Okay, Q cross sigma union epsilon cross tau into Q cross tau star. Okay, and this is initial state. Every automata must have initial state, so that one of the state must be initial state. Generally we take Q naught, that is the reason. Okay, otherwise you can take anything, and initial state is also one of the state from Q. Now in PDA there is a stack. In PDA we use a stack. So whenever machine starts, okay, there will be only one symbol. Whenever machine starts, there will be only one symbol, that is initial stack symbol. So that is the reason stack is non-empty, means the stack alphabet, tau is the stack alphabet, finite non-empty. Why? Because Z0 is the, whenever machine starts, there will be only one symbol in the stack, that is initial stack symbol. So there is no stack symbol, no transaction. Initial stack symbol or initial push down symbol, and every push down symbol is belongs to tau. Every push down symbol is from this alphabet. I repeat, whenever PDA starts, there will be only one symbol in the stack, that is initial stack symbol. No symbol in the stack, no transaction. Okay, then this is, as usual, you know very well, set of final states. Maybe 1 or 2 or 3 or more, or it can be empty also. Simply set of final states, maybe 0, maybe 1, maybe 2, maybe 3, so on. Okay guys, I repeat, finite non-empty set of states, finite set of inputs, okay, finite set of stack symbols, stack symbol non-empty, non-empty. Why? Because z0, minimum z0 will be there. Z0 is a belongs to tau, so that is the reason it is non-empty. Initial state, final states, and tran function we will see later. Just copy. Copy, we'll see. There. Okay, now guys, 7 tuple. Okay, done. Everything is done. Set of states, set of inputs, and set of stack symbols, initial state, initial stack symbol, and final state, except trans function. What is trans function? We will discuss this, then we will go for next. So, transition function delta is defined like this: Q cross sigma union epsilon cross tau into Q cross tau star. Okay now? So that is what we have seen. Okay, now just listen. You need not to write, just listen as a story. Okay, no need to write. Now, what does it mean? For a while, I'll delete this one for better understanding. I delete this one. So, it is Q cross sigma cross tau. What does it means? In every transaction, it takes a state, takes an input symbol, and takes a stack symbol. Why? Because Q represents states, sigma represents inputs, tau represents stack symbol. Okay, I repeat. In every transaction, the Turing machine takes the present state, present input symbol, and top symbol from the stack. I repeat. Q represents state, sigma represents input symbol, tau represents stack alphabet. So in every transaction, it takes the present state and present input symbol and topmost symbol from the stack. Okay, actually there is an input buffer. In the input buffer there will be an input string, suppose A, B something, and this is, so there is a read only head means it cannot rewrite, and there this is connected to an automata will be in some state, that will be Q0, and here there is a stack, this is stack, there is a stack, and stack is used to push or pop the symbols. So here I repeat, in every transaction it takes the, see this is structure actually, there is a tape, okay, means input buffer, actually input buffer not tape, okay, let it be input buffer. In input buffer we will take a input string, and stack will be there. I already told you stack will be there. Stack is used to store the symbols, and state it is connected to automata. Okay, the finite control mechanism. Okay, so in every transaction it takes the present state. Every automata will be in some state. Okay, present state and the present input symbol and topmost symbol. Let these are the symbols Z0, Z1, Z2, Z3 and Z4. So like this, every time it takes the top symbol only. When Z4 is the top symbol, it cannot take any of Z2, Z3, Z2, Z1, Z0. It can only take Z4. So a stack, when you want to take the one symbol, you have to take the top symbol only. Leaving the top symbol, you cannot take any symbol below the top symbols. So it takes, suppose Z3 is not there, Z is not there, then Z4 is not there, then what is the top symbol here? Its top symbol is Z3. So it takes the Z3 from the stack. I repeat, there will be input buffer. In the input buffer, input string will be there. There will be a stacks to store the symbols. Okay, so in every transaction it takes the present state, because this is an automata. Okay, it is connected to the read head. This input buffer is connected to this finite control mechanism, and this stack is connected to this finite control. So here it takes the present state and present input symbol and topmost symbol. Okay, then okay, it takes the present state and present input symbol and the topmost symbol. After that, what is this? What is the next state? Okay, now what is the next state? So because it gives Q is next state, and this is next state, and what to do in the stack? The tau represents the stack alphabet. Guys, listen. Even though you don't get anything, no problem, just keep listening, automatically it will come. Okay, so it takes the state and input symbol, because this is the structure. I have given the structure, na, this one, that is I am explaining. This one I am explaining. So here it takes a state and input symbol and topmost symbol from the stack. After that, what is the next state? Maybe same, maybe different. And this represents stack symbols. So what to do in the stack? So this is the in general. So here that is what. So it takes the state and input symbol. So PDA also scan the string from left to right, and one by one. It scans this first symbol first. After that, it scans the next symbol. After that, it scans the next symbol. After that, next symbol. After that, next symbol. So every time it scans the input symbol and it will do some transaction. Again it will move. Then it will suppose here this is after scanning it will do some transaction. After completion of this transaction, the read head will go to the scanning the next input symbol, and again it will do some transaction. After completion of this transaction, the read head moves to the next input symbol, and it takes this one and take this one and take this one. It will do some transaction like this. So in every transaction, the PDA takes the present state. This is the PDA, guys. Okay, in every transaction the PDA The PDA takes the present state and present symbol from the input buffer, present symbol from the input buffer and topmost symbol from the stack. It takes the present state, present input symbol and topmost symbol from the stack. After that, where to go, to which state to go, to which state to go. That state may be same state, it can be remain in the same state after completion of this transaction, or it may go to different state. After that alpha means what to do in the stack. That is what? That is tau star. What is tau star? We will see slowly. Okay na? So now guys, look at this one. The elements of the transition function are of the form, the elements of the trans function are of the form delta of, it takes a state and input symbol and topmost symbol from the stack and gives what is the next state and what is the next state and what to do in the stack. This is where Q and Q dash are the states. Q, it is a state and it is also state. A is an input symbol. Z is a stack alphabet, and alpha is combination of stack symbols. So Z is a topmost stack symbol and this is, okay, just you copy this one. Okay, now we'll see the example now. We'll see how the transaction can be happen. Okay. Okay, now we see, just for understanding only I am taking, so you need not to copy this one, you need not to copy, because so many of designs we will do. Just what happens in every transaction, that is what I want to explain now. Okay, now suppose there is a situation like this. Okay, so just now I told you, in every transaction it takes the present state and present input symbol and topmost symbol from the stack. After that, what is the next state, what to do in the stack. This is what it will be decided after every transaction. Okay, now guys, now actually, now here this is the present situation. Okay, means what? Here the present state is Q0, the present state is Q0, and the input string to be scanned is AA, the PDA scan the string one by one, left to right. First it scan this, it will do some transaction, then this, then this, then this. So after scanning of every transaction, it will do some transaction, then only it will move to the next symbol. Okay, what is the present input symbol? A is the present symbol. When this is the present input symbol, it cannot scan any of these symbols because A is already there. So after scanning this, then only it will go to next input symbol. So input string will be scanned from left to right. Okay. Now what is the top symbol in the stack? Suppose it was Z0. Sorry. Okay, I'll do one thing. For example, let these are the symbols in the stack. Don't copy, just listen. These are the symbols in the stack. Z0, Z1, Z2, say Z3. These are the symbols from top to bottom. From top to bottom. First we read the top symbol. What is that? Z3. And below that Z2. Below that Z1. Below that Z0. Let these are the symbols in the stack from top to bottom. Sir, how you have taken? Why did you take Q0? Why did you take WAWB? Why you have taken only 4 symbols? Why you have taken input and stack symbols are same length? No. You just don't bother about that all. Even I don't know why I have taken this and that. I want to expand something accordingly. Whatever I am getting in my mind, I am doing that. That's it. Okay. You just concentrating what I am going to say, but don't think about any other doubts and unnecessarily don't type anything. Okay, na? Whatever the doubts you will get, I know what are the common doubts you will get. All those doubts automatically will be cleared from me. Okay. Now, so guys, listen. So let this is the input string, and these are the symbols in the stack. Okay. Now, in every transaction, it takes the present state and present input symbol and the topmost symbol. The topmost symbol is Z3. Are you following? In every transaction, it takes the present state, present input symbol and the topmost symbol from the stack. Okay, guys. Okay, this is example. This is the present situation. What is the present situation? Machine is in Q0 and this is the input string and these are the symbols. But even though there are so many symbols in the stack, even though there are so many symbols in the input buffer, the PDA takes only present state and the leftmost symbol and the top symbol in the stack. Okay, guys. Whenever we do the design, so according to our requirement, we do the design. Example, you are writing a C program. You don't write the same logic for every program. Na? So according to the requirement, you write the logic. Suppose you want to produce the prime numbers. Okay. So according to the logic you write. Suppose if you want to check whether a number is perfect number, so accordingly you write the logic. You don't write the same logic for all problems. Na? So the same way we do the design as per our requirement. Example, I am doing the design like this. Suppose Q0 A, I am writing like this. Example, Q0 epsilon. So you just focus on what will happen if this is the present situation, what will happen in the next transaction. You please concentrate on that only. Okay, guys, here this is the present state Q0 and present input symbol A and topmost symbol Z3. Okay, there may be thousands of moves like this. Okay, so the PDA will searches for the corresponding move which is matching with the present situation. What is the present situation? Q0 is the state and input symbol is A and top symbol is Z3. Even though there are thousands of moves, whatever the move is matched with the present situation, Q0, A, Z3, yes, it is matching with this move. The present situation is matching with that move. Okay, what happens? What is the meaning of this one? Whenever machine is in Q0 and present input symbol is A and top symbol is Z3, so what is the next state? Q0 means be in the same state. Don't change the state. That is the meaning of this one. Q0 means same state. Don't change the state. Now guys, what is the meaning of epsilon? That is important here. Okay, I repeat, the meaning of this one is whenever machine is in Q0, present input symbol is A and top symbol in the stack is Z3, then what is the next state? Q0 means be in the same state. Be in the same state. Okay guys, what is this? This affects, this is the result of the stack. That means what is the top symbol at present here? Z3. And what I wrote here, did I write the Z3? No, I didn't write the Z3. But what I wrote epsilon. What does it means? What does it means? Okay, what is the top symbol here? The top symbol is Z3. Did I write the Z3? No, I didn't write the Z3. Instead of that, what I wrote here? Epsilon. That means, guys, listen. You have to understand what is the meaning of the move. If you can understand what is the meaning of the move, how the PDA will make the transaction. If all these concepts, if you understand, you can write the, okay, you can do the designs. Okay, now. Example, see, here you are going to write a C program. So, when initially, I am not, whenever we learn C language, we don't learn the logic. First we learn the syntax of the language. So, how to start the C program, what we must add initially, all these concepts we will learn. Then, while writing the program, then we will go for the logic as per our requirement. So similarly, here I am not doing any design. I am explaining you what will happen, how to write, if any move is there, what is the meaning of this one, what will happen exactly. That is what I am going to explain now. Now listen guys. So what is the meaning of this one? Whenever state is in Q0, input symbol is A and top symbol is Z3, means the present situation must be matched with this and this and this. Okay, then what is the next state? Same state. Q0, same state. Here what I wrote? Epsilon. That indicates what is the top symbol here? Top symbol is Z3. So that Z3 I didn't write, but what I wrote epsilon. That means the top symbol Z3 you delete from the stack. I repeat, here epsilon means the top symbol Z3 you delete from the stack. Okay na? Now guys, listen. Okay, Q0 A Z3. Okay, so this is the stack Z0, Z1, Z2, Z3. These are the symbols on top of the stack. The present machine is this Q0 A comma Z3. Okay, it is matching. So what is the output here? What is the next what is the result of this one? So where it is going, which state is going? It is going to the same state. Hello. Here the machine has scanned A. Then what will be the remaining input string? ABB. Actually in the input buffer AA is there. After reading this input symbol, the machine move to the next input symbol. Okay, but here if I write AA, you may not understand. Na? So that is the reason I have taken, means whatever the leftmost symbol, that is the present input symbol. So it has scanned A. Then what is the remaining input string? The remaining input string A. Okay guys. Okay. Now what is the meaning of epsilon? So I repeat, Q0 A Z3 go to the same state, be in the same state, and input string is reduced. Why? Because the machine has scanned A. That is the remaining input string. Okay. Now what is this epsilon? Means whatever the top symbol in the stack, you delete it. Okay. I delete. Then what will be remaining inputs? Remaining symbols in the stack? Z2, Z1, Z0. This is from top to bottom. Okay. Are you following? Next, so Q naught A Z2. Why Q naught? Same state and remaining input string A double B. And if I delete Z2, Z1, Z0. Okay na? Now guys listen. So okay, now what is the present situation? What is the present situation? Machine is in state Q naught. What is the present input symbol from left to right? A. What is the top symbol? Z2. Okay. Suppose I am defining the move like this. Q naught A Z2. Okay guys, listen. What is the meaning? What is the meaning of this move? What is the meaning of this move? I am explaining. When the machine is in Q naught, present input symbol in the input buffer, or when the machines take the input symbol A, I repeat, when the machine is in state Q naught, when it takes A, when reads A, if the top symbol in the stack is Z2, I repeat, when the machine is in state Q naught and input symbol is A and top symbol in the stack is Z2. So guys, have you noticed here? I have changed the state. Sir, why did you change the state? I don't know, boss. I want to explain the meaning of the move. So don't search for the meaning behind the design behind this move. Okay? Are you following? You just concentrate what is the meaning of the move. So if it is defined, what will be happen? Okay na? So how did you write this? Why did you change this state? So don't ask me and don't let these doubts in your mind. Okay? So simply you just concentrate what is the meaning. If the machine is in Q naught and present input symbol is A and top symbol is Z2. Okay, if the machine is in Q naught, present symbol is A and top symbol is Z3. So be in the same state, delete the top symbol Z3. Whereas here Q naught A Z2, Q naught must be the same, state must be Q naught, input symbol must be A and top symbol in the stack must be Z2. These three must be at the coincide. State must be Q naught, A input symbol must be A and top symbol must be Z2. Then where to go? Go to Q1, change the state. And guys, what is the top symbol here? Z2. And what I wrote here? Z2 means, what is the meaning of this one, guys? Z2 means whatever the top symbol the machine is scanning. What is the machine scanning? Z2. Where after completion of Z2 will be Z2 only. Means don't touch the stack. Are you following? When the machine is in state Q naught, input symbol is A, top symbol is Z2, go to Q1 and I wrote Z2, which is this Z2, means whatever the top symbol in the stack, the top symbol, don't touch it. You just keep as it is. Okay na? Now look at this one. Q naught A Z2. This is a machine. Machine is here. Actually we are doing this operation we are doing here using this. Okay, example, you have written a program which to check whether a given number is perfect number or not. So program is this. We are passing the input like this. Okay na? So Q naught A Z2, Q naught A Z2, matching with the first move or second move? Second move, because Q naught A Z2 Z2. Now what is the result of that one? Go to Q1. Okay. Change the machine to Q1. Okay. After scanning this, what are the remaining input symbols? BB. Hello. Z2 means the top symbol. Sir, why are you not writing all symbols? Here we never write all the symbols. Okay. Just these are the moves. That is the design. So Z2 means you keep the Z2 as it is. Don't touch. When I don't touch Z top symbol, and always the bottom symbol will be as it is. Z2, Z1, Z0. Okay na? Now guys, okay, what is the present situation? The present situation is Q1 and B Z2. Q1 B Z2. Suppose it is defined like this. Suppose Q1 B Z2. Q1 B Z2. Q1 B. Example, I have defined like this. What is the meaning of the third move? First move, second move, third move. What is the meaning of third move? Whenever machine is in Q1, if the present input symbol is B, I repeat, whenever machine is in Q1, present input symbol is B and the topmost symbol in the stack is Z2, then what is the state here? Q1 means be in the same state. Don't change the state. Q1 B Z2, be in the same state. Okay, what is this, guys? Hello guys, here actually it is Z2 na, but I didn't write Z2. Instead of what I wrote, are you following? Z2, it must be Z2. No, Z2 is not there, but instead of Z2 what I wrote? B. That means the top symbol Z2, you delete it and in that place you write the B. Means simply replace the top symbol Z2, replace the top symbol Z2 with B. That is the meaning. Okay na? Now look at this, guys. So Q1 B Z2, Q1 B Z2, not matching with this, not matching with this, matching with this, Q1 B Z2. So go to Q1 means be in the same state. Okay, be in the same state. Okay, after scanning the remaining input string. Okay, so Z2 place I wrote B. That means you delete the Z2 and replace with B. Okay, B Z1 Z0. Okay, guys, listen. First input string is AA B. In the next level it is A B, next level B, next level B, next level epsilon. So the input string is reducing one by one. Why? The machine is scanning the input string. Whenever the machine is scanning the input string, the head goes to the next input symbol, so on. So that is the reason the meaning of this one, it has scanned A and remaining. It has scanned A remaining. It has scanned B remaining. Okay, that's one. Now guys, look at this one. In the first step, we have not changed the state. But in the second step, we have changed the state. Again in the third step, we have not changed the state. That means after completion of every transaction, the PDA may change the state, or may not change the state like this. Okay. In the first transaction, the top symbol Z3 we have deleted. In the second transaction, the top symbol Z2 we kept as it is. In the third transaction, Z2 we have deleted and we replaced with B. Whereas in the first move, we have just deleted the top symbol, but we didn't touch the top symbol. But in this third move, Z2 we have deleted, but we replaced with means we deleted Z2 and we pushed the P. Simply we pushed the B. Simply we are replacing Z2 with B. Okay guys. Listen carefully. Okay. Suppose I write B. Suppose I write double B. What is the meaning of this one? What is the Q1 comma B comma Z equal to Q1 comma double B? This means the top symbol Z2, the top symbol Z2, whatever the top symbol, this you delete it and in that place push B, push double B. It doesn't mean that double B in the same. No, not like this. Double B, you are pushing the elements one, next, like this. Okay na? So B and B. Okay na? Two B's. Two B's will be pushed by popping the Z2. Suppose I write like this. What does it mean? You delete the Z2, push 3 B's. Or if I write like this, what does it mean? Push 4 B's, push 5 B's, push 6 B's, 7 B's, 8 B's, 9 B's. You can push any number of symbols in the stack because stack is of infinite. Are you following? So here Q1 comma B comma Z2 means whenever machine is in Q1 and input symbol is B and the top symbol is Z2, same state. Don't change the state. Of course, I can change the state also. So everything it depends on the requirement. However, in the case of construction of DFAs, with some states we have gone to other state, and sometimes we have in the same state. Sometimes we go to other state, and sometimes we have to go to we gone to what is that dead state, trap state. So how we have done? Sometimes we have been in the remains in the same state, and sometimes we have gone to another state, or sometimes we have gone to dead state. Are you following? So these many ways we have constructed the DFAs. Everything we have constructed depends on the requirement. Similarly, here we may delete the top symbol, or we may keep the top symbol, or by deleting the top symbol we may push only one symbol, or we may push two symbols, or three symbols, or four symbols, or five symbols, or six symbols, or seven, any symbols you can push. Or guys listen, if I do like this, what is the meaning of this one? What is the meaning of this one? Here, if I write like this, so guys, Q1 B Z1 Z2, Q1 B Z2. When the machine is in Q1 and input symbol is B and the top symbol is Z2 in the stack, then go to Q2. Sir, why are you going to the Q2? Depends on the requirement. Why you have gone to one state to another state? Or why you have gone to one state to a dead state in the constitution of DFA? Depends on the requirement. So here also Q1 will be depends on the requirement. I can go to Q2 or I can remain the same state. Depends. Okay, it doesn't matter. Okay. Now what is the meaning of this one? The Z2 is this one. Yes, there is a Z2. Means you keep the Z2 this. I wrote the Z2. You keep the Z2. But before that, what I wrote B. What does the meaning of this one? That means after completion of this transaction, you keep the Z2 as it is, but push 1B into the stack. That is the meaning of that move. Do you understand? Here B, Q1 comma B comma Z2 equal to Q1 comma B Z2. This means after finishing this transaction, Z2 is Z2. Okay, means you keep the Z2, but push 1B. If I write like this, what does it means? Push 2 B's. Or if I write like this, what does it means? If I write like this, push 1B. If I write like this, push 2 B's, push 3 B's, push 4 B's, push 5 B's, push 6 B's, any number. So you keep the Z2, push 1B, or 2B, or 3 B's, or 4 B's, or 5 B's, or 6 B's, or 7 B's, or 8 B's, 9 B's, so on. Any number of B's you can push. Are you following? So you keep the Z2 and push, or you delete the Z2, and push any number of B's. Okay na? So guys, finally my conclusion is, so listen, this is the final conclusion. Okay guys, listen. Suppose these are the symbols in the stack from top to bottom, Z2, Z1, Z0. So let it take one more. Okay, it doesn't matter whether so here I discuss. See, top symbol, every time the machine takes the topmost symbol from the stack. I repeat, it takes the only top symbol from the stack, and in every transaction it takes the present state and the present input symbol and the topmost symbol. Guys, listen. In every transaction, it takes the present state and present input symbol and the topmost symbol from the stack. After completion of this transaction, the state may be changed or may not be changed, and input string will be reduced one by one because the machine is scanning, and the top symbol after completion of this transaction, the top symbol you can delete this top symbol, or you can keep as it is, or I can replace Z2 by one input symbol, any input symbol, or okay, by keeping this I can add any number of symbols on top of the stack, or by deleting this top symbol I can add any number of symbols in the stack. Okay, that is what, guys. Listen. Suppose the Z2 is the top symbol. After completion of this transaction, you can delete, or you can keep, or you can replace, or by keeping you can add one or more symbols, or by deleting also you can add one or more symbols. But if Z2 is the top symbol in this transaction, you can do anything with Z2. You keep it, or you delete it, or you replace it, or by keeping you can add one or more, or by deleting also you can add one or more. But in this particular transaction, sir, I do like this, sir. Z2 I delete, and Z1 also I delete. No, you cannot touch the Z1. No, sir, I will do one like this, and I replace the Z2 with A and Z1 with B or something. No. When top symbol is Z2, in this particular transaction, you cannot access any symbols in the bottom of the stack. You cannot access, you cannot touch them, you cannot replace or you cannot delete, you cannot do anything. Suppose guys, suppose in this transaction, after completion of this transaction, this top symbol is deleted. Example like this. Now for the next transaction, when the machine do the next transaction, it take the top symbol from the stack. What is the top symbol here? Z1. So now you do anything with Z1, you replace or you keep, or by keeping you can add one or more, or by deleting also you can add one or more, but you cannot touch the symbols which are below the Z1. That's guys, this is what, even though you have received only 10 minutes or 10% or 20% or 50%, or no sir I slept, no problem. Okay na? You just, so your presence is important, so you will get everything. Okay na? Now look at this guys. I'll give you some notes. You just copy. I don't dictate. If I dictate, some of you may continue or some of you may be missed. So I'll write here. What was the last one? This is not at all required guys. This is not at all required. You can delete this one. You don't copy. Take this. Copy this one. In every transaction, takes the present state. In every transaction, the PDA takes the present state, comma, okay, present state, comma, present input symbol, present input symbol, and the topmost symbol, topmost symbol is here, top to bottom, topmost symbol from the stack. Okay. After completion of each transaction, the PDA may or may not change the state, the PDA may or may not change the state. Okay, see, from year to year no change in the state, but from year to year there is a change in the state, but from year to year again no change, or you can change. Okay, so after completion of every transaction, the PDA may change or may not change the state, and the topmost symbol in the stack, this topmost symbol in the stack, this one, or whatever is Z3, it can be deleted or it can be, in this case we have deleted, in this case we have kept as it is, in this case we have done so many things. Okay, so the topmost symbol in the stack may be deleted, means you can delete the symbol, or kept as it is, or kept as it is. The topmost symbol you can have kept as it is, or the topmost symbol may be deleted here, or you kept as it is, or replaced by some other symbol, means with the topmost symbol you can replace with some other symbol, or one or more symbols one or more symbols can be added on top of the stack. You can add any number of symbols, maybe one symbol, you can add one symbol or two symbols or three symbols or four symbols. So one or more symbols can be added on top of the stack. Okay, by deleting means you delete the top symbol, or keeping means you keep the topmost symbol. So see guys, here the Z2 you can keep here, you add one or more symbols, or you delete Z2, you can add one or more symbols. So that is what I am saying. Replaced by some other symbol or one or more symbols can be added on top of the stack by deleting or keeping the topmost symbol. Means the topmost symbol you delete or keep it. You can add one or more symbols, okay, by keeping the topmost symbol in the stack. So you keep the topmost symbol in the stack, or you delete the topmost symbol in the stack. Okay, now one or more symbols can be added on top of the stack by deleting or keeping the topmost symbol in the stack. Okay, but the symbols which are below the topmost symbol, means suppose these are the symbols in the stack. When the machine is taking this symbol, it can keep it, it can delete it, or by keeping you can add one or more symbols, or by deleting also you can add one or more symbols, but you cannot touch this area. This area you cannot access. But the symbols which are below the topmost symbol will not be disturbed. Okay, so copy this guys. मुझे बहुत Surya Bhatnagar, the stack symbols can be anything. You can push any symbols in the stack. Maybe input symbols, maybe some other symbols. Okay, you can push any symbols in the stack. Whatever the symbols you are pushing in the stack, they are called as stack symbols. So input symbols and stack symbols. So whatever the input symbols, same symbols you can push into the stack. Okay, but input symbols and stack symbols are always same? No, not correct, because initial Z0 will be there. Z0 is initial stack symbol, but not is an input symbol. Okay. Yeah, you need not. Okay. Now, actually, the trans function defined on q cross sigma union epsilon cross tau into q cross tau star. Okay, na? What is the meaning of this sigma union epsilon? You remember n of a, in n of a, the trans function defined on in n of a, it takes a state and input symbol, or without input symbol also it can make a transaction and it can go to multiple states 2 power q. This is, so what is the meaning of this one? This means at any state, okay, for any input, it may go to another state, or it may be defined or may not be defined. If it is defined, it can go to same state, or it can go to other state, or it can go to both of them, or one more there, it can go to this also, or guys, here q0 to q1 without taking the input symbol, that is the meaning of this one, sigma union epsilon. It without taking the input symbol from q0 to, you can, the NFA can reach from one state to another state. The NFA can change from one state to another state without reading the input symbol. That are null, those are null moves. Similarly, in PDA also, the, okay, it can make a transaction without taking the input symbol. Example, suppose sigma is a comma b, what is sigma union epsilon? This is nothing but a b epsilon, means it can take a or it can take b, or without taking the input. That is the meaning. Okay, so what is the meaning of this one? I will tell you. Listen guys, very clearly I'll tell you. Listen. Suppose q0, okay, and I'm taking the same input string, okay, bb, and suppose there is a z2, and I define like this, q0 a z2. Suppose I am defining like this, q1 and epsilon. Example, what is the meaning of this one? When the machine is in q0, input symbol is a. When machine is in q0, input symbol is a, top is z2, q0 state, input symbol is a, top symbol is z2, go to q1, change the state to q1, and epsilon means you delete the top symbol z2. Epsilon means you delete the top symbol z2. So what happens here? Hello guys. Q0 A Z2. It is matching with this situation. Go to Q1, change the state to Q1. Here the machine has scanned A. If it has scanned A, the remaining input string is A, B, B, and delete karo. Aisa. Otherwise, okay. Suppose I am taking this some more symbols here, Z2, Z1, Z0. Okay. If I delete epsilon, if I delete, what will be, if I delete the top symbol, what is the meaning of this one? Epsilon, delete the top symbol. Then what will be the remaining input symbols? Z1, remaining stack symbols. Are you following? There is a stack. In the stack, bottom is Z2, and top of it Z1, and top of it Z2. So presently the machine is taking Q0 A Z2, top symbol Z2. After this, I wrote that delete the stack symbol. Means you delete this symbol. Okay, I have deleted. Now what is for the next transaction? What is the machine? What is the machine takes which symbol from the stack? Whatever the top symbol. What is the top symbol? This is the top symbol. Okay, na? Now guys listen. Important. So here the machine is in Q1 and input symbol is A and top symbol is Z1. Okay, na? The machine is in Q1, input symbol is A, top symbol is Z1. Okay, Q1, comma, A, comma, Z1. If I define something, suppose Q1, Z1, means you be in the same state, same stack symbol. Don't touch. Okay, it will be done. Suppose I don't define anything. Means empty. I have not defined anything. If you don't define, example, in the finite automata, the machine is in Q0. If you define Q0 on A, after this it will goes to the Q0. Otherwise, if you don't define, the machine stops. Na? When you don't define, the machine stops. Na? Similarly, if you don't define, when you are not defining, even you need not to write. Machine is in Q1 A Z1. Q1 A Z1 is not there. Look at this one. The machine is in Q1. Input symbol is A. Top symbol is Z1. There is no move. The machine stops. Are you following? What is the state, guys? Q1. What is the present input symbol? A. Top symbol Z1. Q1, A, Z1. What? Where is the move? No. When there is no move, the machine stops. Okay. Now look at this. I am writing one move. You just understand what is the meaning of this move. Q1 epsilon Z1 equal to, suppose, Q2 A. Example. Hello guys. What is the meaning of this one? The meaning of this one is, listen, important. The meaning of this one is, whenever machine is in Q1, when input string is empty, are you following? Whenever machine is in Q1, when the input string is empty, no, it is not the meaning of that one. Are you following? When the machine is in Q1, input string is empty, no. It is not the meaning like this. Okay, and if anyone is thinking like that, it is wrong. Okay, what is the actual meaning of this move? It is not the meaning of this move is not like when the machine is in Q1, input string is empty. No, it is not like that. What is the actual meaning of this one? The actual meaning of this one is, when the machine is in Q1, and when the top symbol in the stack is Z1, are you following? Machine must be in Q1 and top symbol must be Z1. Then the meaning of this one is, whenever state is Q1, top symbol is Z1, don't take the input symbol. Means without taking the input symbol, however we change the state from one state to another state, so similarly in the same way, without taking the input symbol, you do the transaction. That is the meaning of this move. Okay, I repeat, when state is Q1, top is Z1, don't take the input symbol and do this. What? Q1, from Q1 you change to Q2 state, and A, what is the top symbol? Z1. I didn't write the Z1 here. I didn't write the Z1, but what I wrote? I wrote A. What is the meaning of this one? Suppose guys, if I write like this, what is the meaning of this one? Top symbol Z1, here also Z1. So you keep the Z1 and on top of it you push A. But here what I wrote here? Here I didn't write the Z1. I wrote only A. What is the meaning of this one? After completion of this one, go to Q2 and replace Z1 with A. Okay guys, listen. Okay, now listen. Q1 comma A comma Z1 is not there. Q1 comma A comma Z1 is not there. But what is there? Q1 comma epsilon comma Z1 is there. Means whenever state is Q1 and top symbol is Z1, make a null move. Don't take the input symbol. Where to go? Q2. Go to Q2. Okay guys, hello. Are we taking the input symbol? Did I take the input symbol? No. When I don't take the input symbol, the same input string will be carried for the next transaction. Same input string. And what is the meaning of this one? You replace Z1 with A. So this will be the result. Okay. From here to here, the here input string is AA, but from here the input string is ABB. Here the input string length is 4, here 3. But then here also same. Here ABB, here also ABB. From here to here the input string is not reduced. But here to here input string is reduced. From here to here input string is reduced. Why? Because the machine has scanned A. But from here to here the machine is not, the string is not reduced. The string is not reduced. Why? Because the machine has not scanned the input symbol. It has made a null transaction. Okay na? This is the meaning of null move. So guys, listen. Take next point. Sometimes the PDA can make a transaction without taking the input symbol. Sometimes the PDA can make a transaction without taking the input symbol. Such moves are called as null moves. That is del of Q comma epsilon comma Z. This is Q guys. Okay, copy this. Next point. Okay. Sir, don't you feel cold? Why are you asking, Madhusudan? I am not feeling cold. It's normal temperature. I am in Delhi. I am not in Kashmir. Chale? Now guys, ID, instantaneous description. ID, instantaneous instantaneous description. ID, instantaneous description. ID. What is an ID? What is an ID? An ID is delta of Q comma W comma alpha, where Q is a state, W is a string, and alpha is a set of stack symbols. Okay, copy this, guys. An ID is no, here it is not cold, Madhu. Here is normal temperature only. Okay, an ID is Q comma W comma alpha. That means, what does it means? It tells you what is the present state, and what is the present input string and symbols in the stack from top to bottom. Example, see, I think we have, say, this is an ID, this is an ID, this is an ID, this is an ID. Here state is Q0, string is WABB, symbols from top to bottom Z3, Z2, Z1, Z0. Here this is an ID, this is an ID. Here what is the meaning? State is Q1, input string is WB, and symbols in the stack from top to bottom. Symbols in the stack from top to bottom Z2, Z1, Z0. So everything, example, this is an ID, state is Q0, WABB, and Z2, Z1, Z0. So example, what is the ID? Here example, we will go for example. Example, delta of Q1 comma ABA and Z2 Z1 Z0. So this is an ID, means the Q1 is state, ABA is W, alpha is Z2 Z1 Z0. Are you following? Q1 represent this, W this ABA, alpha Z2 Z1 Z0. Okay na? This is ID. Okay, next one, initial ID. This is important, guys. Initial ID, guys. Really, PDA is very interesting topic. Okay, when we complete the concept, One question I'll tell you very clearly, in depth I'll tell you, but after second question onwards I don't go for in depth, just what is the design I'll give you. But if you are interested in logic while doing the design, you will enjoy. Okay? Now, initial ID. What is initial ID? If m equal to q sigma tau delta q naught, q sigma tau delta q naught z naught, f is a PDA, then the initial ID is delta of q naught. What is q naught, guys? This means by giving the structure, what will you understand? You will understand what are the states, what are the inputs, what are the stack symbols, and what is initial state, what is initial stack symbol, what are the final state, what is trans function. You will know everything. So if this is the push down automata, then what is the initial ID? Initial ID means whenever machine starts, it must start from the initial state. It must start from the initial state. That is the reason I have taken q naught. And string can be anything, guys. String can be anything. So if it is valid, it will be accepted. If it is invalid, it will be rejected. So q naught w comma, whenever machine starts, it must start. Okay, whenever machine start in the stack, there will be only one and only symbol in the stack, that is initial stack symbol. I repeat, guys, when the machine starts, it must start from the initial state q naught. And what is the string? You take any string, maybe valid and invalid. And in the stack, there will be only one symbol, that is initial stack symbol. So z naught initial stack symbol, q naught initial state. And what is w? Where w is any combination of input symbols. If it is valid, it will be accepted. If it is invalid, it will be rejected. So this is initial ID. Next. Okay. Next important topic. Okay. Next one more point. In PDA, take as a note. Did I give this note or not? No. In PDA, it is not necessary to define for every combination of for every combination of, in PDA it is not necessary to define for every combination of, for every combination of, every combination of delta of q comma a comma z, where q is a state and a is a input string, z is a stack symbol. Okay, so it is not necessary to define for every combination of, so whatever we required we define for them only. So for every state, for every input symbol, state is q is state, input symbol is a, z is stack symbol. It is not necessary. Whatever we required we define for them only. Thank you, Ankit. Okay, next, where q, got it? Now we'll go for next concept, acceptance by PDA. Acceptance by PDA. Acceptance by PDA. Now tell me how can you say that a string is accepted by finite automata? How do you say that a string is accepted by finite automata? By starting at initial state, if the machine reaches some final state. In the case of finite automata, a string is said to be accepted. You start from initial after, see, suppose this is the input string. It has to scan complete input string. The input string must be scanned completely. When the machine stops, it must stop in a final state. Suppose A, B, B, A, B, A, or something here. So this string must be scanned completely. Suppose it has scanned only here. It has stopped, but it has stopped in a final state. But string is not scanned. Completely. Then the string is not accepted. Okay, na? Suppose it has scanned the string completely here and here and here, and it has reached a non-final, then also not accepted. Suppose the string has scanned completely and the machine has reached the final state, then the string is accepted. The same concept here also we do. So in the case of finite automata, it has to start from initial state, whereas in the case of PDA it has to start from initial ID. Are you following? In the case of finite automata, we start from initial state, whereas in the case of PDA, it must start from initial ID. I repeat, in the case of finite automata, we start from initial state and we stop in a final state, and string must be scanned completely. Here also same. In the case of push down automata, here also in the case of push down automata, it must start from initial position. What is that initial position? Nothing but initial ID. Okay, na? Now guys, take. A PDA can accept the strings in two ways. A PDA can accept the strings in two ways. One is by final state, and by empty stack. By final state or by empty stack. Copy this. Okay. Now, by final state. First one, by final state. Guys, listen. If m equal to q sigma tau del q naught z naught f is a PDA, and if it is accepting if m equal to q sigma tau delta q naught z naught f is a PDA, and if it is accepting the strings by final state. One second guys, one second. If m equal to is a PDA, better I change this. Okay. Then the set of all strings, the set of all strings, then the set of if m equal to is a PDA, then the set of all strings accepted by PDA by final state are defined as. Simple guys, same whatever I have written earlier, the same, but just I have changed this some word framing, that's it. If m equal to is a PDA, then the set of all strings accepted by PDA by final state are defined as. Now look at this guys. L equal to okay, set of all strings, set is L equal to L of m means the language, m is the PDA, L of m means the language accepted by machine. I repeat guys, suppose this is the PDA. PDA structure, just that's I have given structure, states, inputs, stack symbols and trans function, initial state and initial stack symbol, final state. It is a machine. If it is a PDA, then the set of all strings acts by this PDA by final state. L of M. L of M means L is language. L of M means the language acts by machine M is defined as, guys, listen, we came back. So guys, a string is said to be accepted by finite automata if it starts at initial state. Here also same. If it starts at initial ID, okay, set of strings. Strings nothing but combination of inputs, okay. Okay, inputs. Are you following? Sigma star is the input such that set of all strings. So in the case of finite automata, it has to start from initial state. In the case of push down automata, it has to start from initial ID. In the case of finite automata, hello guys, are you sleeping? Huh? Theory zyada ho gayi na? Listen. So in the case of finite automata, it has to start from initial state. In the case of PDA, we start from initial ID. What is initial ID? Q naught W Z naught. So same I have written Q naught W Z naught. After one or more transactions, by final state means it must reach the one of the final state. Are you following? QF. One of the final state, any final state. If there are more than one final state, it can reach any final state, comma, epsilon. That epsilon indicates the string must be scanned completely. That is the meaning, okay na? And hello guys, when the machine starts, we start from initial stack symbol, that is Z0. When we do the transaction, we may push the symbols, we may pop the symbols. Hello, when the machine stops finally, it must stop in final state. The string must be empty. The string must be scanned completely. And stack also can be empty. The stack also. But three conditions must be satisfied compulsory. What are they? It has to start from initial ID and it must stop in a final state. When the machine stops, then string should not be left anything. Any symbol should not be left in the string. And when the machine stops, there may be stack also may be empty. It may have one symbol or two symbols or three symbols or four symbols or any symbols. We never bother about the stack. Only three conditions. Start from initial ID, stop in final, and string must be empty. That's it. And then what about the stack? Stack can be anything. It can be empty or it can be non-empty. So alpha. What is alpha here? Any combination of push down symbols where QF is a final state. And alpha is any combination of stacks symbols. Okay, copy this guys. By final state. Okay. Copy. Thank you, Madhusudan. Okay guys, now next one, by empty stack, by empty stack. So guys, so I repeat, this is very important. If a PDA is accepting the strings by final state, it must reach from the it must start from the initial ID. It must start from the guys, I repeat, if the PDA is accepted the strings by final state, it must start from the initial ID, compulsory initial ID, and it must stop in a final state, and string must be completely scanned. Same in finite automata also. It must start from initial state in the finite automata. Here it must start from initial ID. In the finite automata also, it must stop in a final state, string must be empty. Here also, stop in a final state, string must be empty. What about the stack? Anything. It may be stack empty, or maybe one symbol, two symbols, any number of symbols, doesn't matter. Okay. Now count to by empty stack. Guys, whenever you are accepting the strings by empty stack, if m equal to q sigma tau delta q naught z naught, hello guys, when you are designing the PDA by empty stack, we don't define the final states. Sir, is it compulsory? No boss, you take the final state. When you are taking the final state, means are you accepting by empty stack or final state? What is the, so the PDA must have some clarity, na? So should I accept by final state, or should I accept by empty stack? So the PDA asks you, so what will you say? So you have to give any guarantee that, so you accept by empty stack, no, you accept by final state. So the PDA can accept the strings in two ways, by reaching the final state or by emptying the stack. So when you are accepting the strings by empty stack, don't define the final state. Okay, don't define the final state. So is the PDA, then the set of all strings accepted by PDA, set of all strings accepted by PDA by empty stack, or defined as, hello guys, suppose this is the PDA, and if it is accepting the strings by empty stack, then all the strings defined by all the strings are defined as like this. L of m, just before I told you, L of m is a machine, L is a language, L of m means the language accepted by m. So here also the language accepted by machine m. So set of strings, strings are combinations of input symbols, okay, whether you are accepting by empty stack or final state, by empty stack or final state, you must start from the machine. You means the machine. The machine must start from initial ID. It must start from initial ID. Initial ID Q naught comma W comma Z naught. After one or more transactions, the meaning of this one is after one or more transactions, okay, it must when the machine stops, it must stop in the case of final state. It must stop in the final state. Whereas by empty stack, hello, there is no final state. Are you following? In the case of by final state, it must stop in a final state because we are accepting by final state, and string must be empty. Stack anything. Same here also. Here see, by empty stack means we are accepting the strings by empty stack. The name itself can tell you the meaning. Empty stack. Stack ko empty karo. Then what about the state? State can be anything because we are not using the final state. So you reach any state. So Q dash. And guys, whatever the string you are taking, it must be read completely. So what are the common in the final state and empty stack? In the case of final state, it must start initial ID. Here also initial ID. After one or more transactions, it must reach the final state. Here it can reach any state because no final state. It can reach any state. Here string must be scanned completely. Here also string must be scanned completely. So what are common? Initial ID common. String must be scanned completely. This is also common. Here it must reach the final. Here it can be reach any state. And here stack can be anything. But here stack must be empty. So stack must be empty. So what is Q dash? Q dash can be any state. Q dash can be any state. Do you understand the similarities? Both must start from initial ID. Both must read the string. Must reach the string completely. Here by empty stack must be empty. Whenever the stack becomes empty, the meaning of stack empty means all the symbols in the stack, if you are delete, the machine immediately stops. So the machine immediately stops if the strings, if the symbols in the stack are not present. I repeat, if the stack becomes empty means if you delete all the symbols from the stack, then stack will become empty. When the stack becomes empty, immediately the machine stops. It cannot move, it cannot make any transaction. It cannot move forward. Okay. So if the machine stops in final, or if the stack empty, I repeat, if the machine stops in final state, or if the stack becomes empty, in both cases string must be empty. Suppose machine has stopped, it has stopped in final, string is not scanned completely, not accepted. Suppose stack is empty, when the stack empty, immediately sudden break, machine stops, but string is not empty, then also not accepted. So both cases, here and there, string must be scanned completely. Okay guys, zyada ho gaya, just copy this. Copy this guys. We'll go for next concept. So have you copied this fine sheet also? No. Copy both. So remember two conditions. बार बार सेम बात बोल रहा हूँ. Remember the same thing I am repeatedly saying you. So the PDA can accept the strings in two ways. One is by final state, the other one is by empty stack. In both cases it must start from the initial ID. In both cases string must be scanned completely. By final state the machine must stop in a final state. Stack can be anything. By empty stack it can reach any state, but stack must be empty. Okay, these are the two conditions. Okay guys, we will go for break and come after 25 minutes. Then we will continue with the what is deterministic PDA, what is DPDA, what is NPDA, what is DPDA accept, what is NPDA accepts. Then we will go for one design. Okay na? First design you may feel, some of you may feel that strange, new, but once if you understand, then you will enjoy the next design onwards. Okay guys, thank you.